We are covering horizontal curves, specifically the degree of curve and stationing calculations, as tested on the FE Civil exam. All the formulas for this topic can be found in the Civil Engineering section of your NCEES Reference Handbook, under Transportation. Let's start with the degree of curve, denoted by D. This term defines the sharpness of the curve. The most common definition on the FE exam is the arc definition, where the degree of curve is the central angle that subtends a 100-foot arc. The formula is D equals 5,729.58 divided by the radius r. A larger degree of curve means a sharper turn and a smaller radius. While a chord definition also exists, which uses a 100-foot chord instead of an arc, the arc definition is the standard for most highway work and what you should expect on the exam. Now, let's talk about the key points on a curve. The PI is the point of intersection, where the two straight tangent lines of the road would cross if there were no curve. The PC, or point of curvature, is where the straight tangent ends and the circular curve begins. The PT, or point of tangency, is where the curve ends and connects to the next tangent. The primary task on the exam is to calculate the stationing for the PC and PT, given the station of the PI, the radius r, and the intersection angle delta. Stationing is simply a measurement system along the center line of the road. To find the PC station, you must first calculate the tangent length, t. The formula is t equals r times the tangent of delta, divided by 2. This length t is the distance from the PI back along the tangent to the PC, and also from the PI forward to the PT. Here is the first major exam trap. The station for the PC is the PI station minus the tangent length t. You are moving backward from the PI to get to the start of the curve. A great way to remember this is the mnemonic. You have to go back in time from the PI to find the PC. This links subtracting the tangent from the point of intersection to get the point of curvature. Once you have the PC station, you need the length of the curve, L, to find the PT station. The formula for L is the radius r multiplied by the intersection angle delta. L equals r times delta. But be very careful. This is the biggest trap on these problems. For this formula, the angle delta must be in radians. The exam will give you delta in degrees, so you must convert it by multiplying by pi over 180. Forgetting this conversion is a very common and costly mistake. After you have the curve length L, the final step is straightforward. The PT station equals the PC station plus L. So let's recap the process with an example. If the PI is at station 20 plus 00, R is 600 feet, and delta is 40 degrees. First, find T. 600 times tan 40 over 2 gives you a tangent length of about 218.3 feet. Next, find the PC station. 2,000 minus 218.3 gives you station 17 plus 81.7. Then calculate L, remembering to convert delta to radians. 600 times 40 times pi over 180 gives a curve length of about 418.9 feet. Finally, find the PT station. 1781.7 plus 418.9 gives you station 22 plus 00.6. Master this sequence. Calculate T, subtract it from PI to get PC. Calculate L using radians, and add L to PC to get PT. This will ensure you handle these questions correctly on exam day. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.